If you've ever found yourself coding and thinking, man, I'm reinventing the wheel here, then you are in exactly the right place. Today, we're diving into a powerful set of tools that can help you write better software and do it faster. We're talking about design patterns. So let me just ask you this. As a developer, do you ever get that sense of déjà vu? You're staring at a problem and it hits you. Wait a second, I have solved this exact type of thing before. Well, you're not going crazy, and you're definitely not alone. There's a whole concept designed to fix this exact feeling. And that concept, of course, is the design pattern. At its heart, a design pattern is just a reusable solution to a problem that shows up again and again in software design. Now, it's not a finished chunk of code you can just copy and paste. Think of it more like a recipe or a template for how to solve a particular problem in a really smart way. Yeah, this is the perfect way to look at it. A design pattern is like a blueprint. I mean, you wouldn't just start building a house without a plan, would you? It'd be chaos. It's the same with software. These are proven, battle-tested blueprints that developers way smarter than me have figured out and refined over years. So here's what we're going to do. We'll quickly touch on what makes these patterns so useful, then we're going to dive into 3 really common ones: the command, observer, and chain of responsibility patterns. And we'll wrap up by looking at how you can think of all of these as essential tools in your developer toolkit. All right, let's get into it. First up is the command pattern. The big idea here is all about turning a request or an action into its own self-contained object. Okay, so imagine you're building a simple text editor. Your user needs to be able to copy text. Simple enough, right? But where does that copy logic live? You could stick it in the copy button's click event, but what about the right-click context menu or the keyboard shortcut Control-C? Pretty soon, you've got the same copy code sprinkled in 3 different places. It's a total maintenance nightmare. And here is a fantastic analogy for how to solve this. Think about a waiter in a restaurant. They take your order and write it down on a little ticket. That ticket, that's the command. It has everything the chef needs to know to make your food. The waiter doesn't need to know how to cook the steak. They just need to pass that ticket, that command, to the kitchen. And that is exactly how this pattern works in our code. We take that request, the copy text action, and we wrap it up in its own neat little object. The button, the menu item, they're just senders. All they do is trigger this command object. Now here's the magic. Because that action is now an object, you can do all sorts of cool stuff with it. You can put it in a list to create an undo-redo history. You can queue them up, you can log them. It totally decouples your user interface from the actual logic. It's so clean. Okay, moving on to our next pattern, the observer. This one is all about creating a clean way for objects to talk to each other and stay updated when something important happens. Let's set up the problem with a real-world example. Say a customer really wants a new product that's out of stock. On one hand, the customer could keep checking the store's website every single day, which is a huge waste of their time. On the other hand, the store could just blast out a mass email to every single customer every time any new product comes in. That's a huge waste of the store's resources, and frankly, it's just spammy. Both of these are pretty terrible options. The solution is this really elegant model called publisher/subscriber. You've got 2 main players. First, there's the publisher. That's the object that has some interesting state people care about. In our example, that's the store's inventory. Then you have subscribers. These are the objects that want to know when the publisher's state changes. That's our eager customer. The best way to think about this is a magazine subscription. You don't drive to the newsstand every morning to see if the new issue is out. No, that's crazy. You subscribe once, and the magazine publisher automatically sends you the new issue right when it comes out. You get notified, but only when it matters. And the publisher only talks to people who've actually said they're interested. So the crucial point here is how incredibly flexible this makes your system. You can add brand new subscribers, maybe a component that tracks inventory for reports, without ever changing a single line of the publisher's code. Objects can subscribe and unsubscribe whenever they want. This is a perfect example of the open/closed principle. Your code is open for extension, but closed for modification. You can add new behaviors without breaking what's already there. All right, our third and final pattern for today is the chain of responsibility. This one is all about passing a request down a line of potential handlers, kind of like an assembly line. So, picture an online ordering system. When an order comes in, you have to do a bunch of things in a specific order. You got to check if the user is logged in, then you have to validate their payment info, then maybe you check a cache to see if you can speed things up. If you cram all of that logic into one giant function, well, you end up with a bloated, tangled mess of if-else statements that's impossible to manage or reuse. The solution is something we've all been through when we call tech support, right? Your call, your request, gets passed along a chain. First, you hit an automated system. If that can't solve your problem, you get passed to a tier 1 operator. If they can't solve it, you get escalated to a senior engineer. Each link in that chain gets a chance to handle your request. And that's exactly how we organize our code with this pattern. We pull out each of those checks, authentication, validation, caching, and turn each one into its own separate handler object. Then we just link these handlers together in a chain. When a request comes in, it starts at the top of the chain and gets passed down, giving each handler a chance to process it or pass it along. This makes your code super flexible. Want to add a new fraud check? Just create a new handler and pop it into the chain. No need to rewrite everything. So, we've looked at 3 different patterns, 3 different problems, and 3 different solutions. But how should we think about them as a whole? Well, the best way is to see them as a powerful and absolutely essential developer toolkit. So let's just do a quick recap. Each pattern is a specialized tool for a specific job, right? When you need to treat an action like an object, maybe for that undo feature we talked about, you reach for the command pattern. When you need different parts of your app to react to changes without being tightly coupled, the observer pattern is your go-to. And when you have a strict series of checks a request needs to go through, the chain of responsibility is going to keep your code clean and organized. And this really is the most important takeaway. Design patterns are so much more than just clever ways to structure code. They give us a shared language. When you tell another developer you used an observer pattern, they know exactly what you mean. You're leveraging proven solutions, and the result is code that is way more flexible, so much easier to reuse, and trust me, 1,000 times simpler to maintain down the road. So, I'll leave you with this final thought. Take a minute and think about a project you're working on right now. What's that one part of the code that's just a tangled mess? That part you're afraid to touch? Now ask yourself, which one of these patterns could be the perfect blueprint to finally straighten it all out?